Hello, I'm Mrs. J, and today we're going to cover Chapter 6, Normal Distribution Concepts. So if we look at this first one, if the area to the left of x in a normal curve is so if we have a normal curve and there's an x. If the area to the left, let's move our x this way, is 0.712. Then the area to the right under the curve adds up to 1. So to find the area to the right, you just subtract from 1. You get 288. If the area to the right of x in a normal distribution is 0.712, the area to the left, this still has to add up to 1, so we take 1 minus it, it's going to be 0.288. And so it's just making sure you understand the area under the curve adds up to 1. This next one says the probability z is greater than b is 0.1. So if we have then the probability negative z is between negative b and b. Well, this is uniform, like both sides of here is exactly the same. So if b is a negative 1.1, then negative b, this would be 0.1. And we know the whole thing adds up to 1, so if we want inside, 1 minus 0.1 minus 0.1. So it would be true. It is 0.8. The mean, which this would be, splits your data in half, so 50% on each side. So that was true. If a distribution is normal, then it is not possible to randomly select a value that is more than 4 standard deviations. Now that's false. Normally, if you have a normal distribution, most of the data is within 3 standard deviations, but that doesn't mean you can't have data higher than that. So that would be false. Okay, these ones, let's see. A set of exam scores is normally distributed with a mean of 74 and a standard deviation of 4. Now, if you look at the normal curve, these are the percents that are set up, and this is our mean, and then going 1 standard deviation, 2, 3, each way. So within 1 standard deviation is 34 and 34, or 68% of the data. And then plus or minus 2 standard deviations, that would go from here to here. So it would be the 213.5s plus the 234s. 95% of the data. And then if we go 3 standard deviations from here to here, we would be adding the two of these. And that's 99.7% of the data. And so in this one we have a mean of 74 and a standard deviation of 4. So if we draw a normal curve, the mean goes in the middle, which we said was 74. And then we're going to go 3 each way. And the standard deviation was 4. So we're counting by 4s. 74 plus 4 would be 78. Adding another 4, 81 and 85. So we just added 4 each time. 78, 82, 86. The other way, we're subtracting it. So we have 70, we have 66 and 62. The percents that we had here stays the same. So the middle is both 34, 13.5, 2.35, and then 0.15. It says find the middle 95%. Well, we said the middle 95% was 2 standard deviations. And if we add from here to here, we will get 95. So the middle 95 is 66 to 82. Because that would be in the middle 95% if you add your data here, or your percents. Find the percent of the exam scores between 70 and 74. 70 to 74, 34%. Between 70 and 74. Percent of exam scores between 74 and 82. 74 to 82. 3.4 plus 34 plus 13.5. 47.5. $78 to 82. 78 to 82 would just be here, so 13.5. And scores greater than or equal to 70. 70 is here, so greater than or equal to would be from here over. And so we'd add all of these up. And when you add them all up, you get 84. The depth of snow in my yard is normally distributed with a mean of 2.5 inches and a standard deviation of a quarter. What is the value 1 standard deviation below the mean? So below 1 standard deviation, we would subtract it. And take 2.5 minus the quarter, and you get 2 1/4. So that's how they got this one. What is the value 1 standard deviation above the mean? Well, then you take your mean and you go 1 above it. So we get 2.75. What is the probability that a random chosen location is between these two values? Well, this was 1 standard deviation above, and this was 1 below. 1 above and 1 below. 68% of our data. Within 1 standard deviation is 68% of the data when it's normally distributed. So it was 68%. Okay, let's do one more. What is the appropriate percentage of students who scored between 72 and 83? Okay, so that graph, the percents, let me draw it again, just so we have the values. So it's 72, 83, 94, 105. And going the other way, it's 39, 50, and 61. This is 34. This was 13.5, 2.35, and 0.15. Okay. What is the approximate percentage of students who scored between 72 and 83? 72 and 83, 34%. What is the approximate percent of students who scored less than 50? Less than 50 is from here over 0.15 plus 2.35, which is the 2.5. What is the approximate percent of students who scored between 39 and 72? 39 to 72. So that would be 39. 2.35, 13.5, 34, and we stop there. So it's these three. And if we add those up, we get 49.85. The last one, what's the approximate students lower than 39? Lower than 39 would be here, which is 0.15.